Hello and welcome to yet another video. Today we have something different. This is not an X470 Aorus gaming Wi-Fi, but these are our Aorus boards from Gigabyte, and there's actually two of them in here. So I can show you. We have one and we have another one right here. So let me get those open up and I will see you then. And here it is. We have two main boards on our board, both the same. Both are Aorus Pro B450, or is it? No, it's actually two a little bit different ones. This is an B450 Aorus Pro, and this one is a B450 Aorus Elite. So a little bit of different boards, but they look very similar in many ways. There are slight differences, like I can already see. There's one fan header here, where there's none here, but there are two here instead of two there. So there are slight differences in this. Sadly, these didn't come with the cover for the M.2 slot, only the single cover came here. I got these of the same seller. He said that both of these are faulty, and I don't really know what specifically is broken with them, what doesn't work. I guess there are just no posts. Good thing is both came with the I/O shield, which is very nice. Don't have the original packaging, only the one that I showed you. Yeah, I don't know if we're going to do both of the boards today, or if we do a single one and then another one in another video. One thing I can already see, the Aorus Pro has boot LEDs. Oh, this one has it also, but in a different place. Okay, so it doesn't really matter with which one we're going to start. So I'm going to pick the Aorus Pro for now, and we might do the Elite afterwards as well. So, before we're going to start to build this one up, let's just get a multimeter in here, and let's take some measurements first. So first simple thing that we're going to do, let's see what our CMOS battery says. And we have 3.0 volts, that is fine. Let's go into resistance mode. And let's check for some resistances. Let's start with 5 VSB, I think this one should be. This looks fine. This is 3.3 volts, this looks fine. Think this is 5 volts and this is 12 volts, and all of these look fine. This should be PS on. This looks also fine. Yeah, so all of these looked very good to begin with. Let's check the 12-pin CPU. This is also fine. And can I probe the PCH? Probably not. So we're not going to do that now. We're going to continue with building up this board, and we're going to see how it reacts and what current it takes, because we have looked for the major things, if there could be any shorts, but there were none. So let's build it up and see how the power consumption of this board will be. And now everything is hooked up. And let's see for the passive power consumption. Oh, that is a lot. We have, if you look at this, we have half an amp. That is very bad. That is very bad. That looks like a short circuit on 5 VSB. Even though we've just checked 5 VSB, if I'm not mistaken. Let me quickly check the pinout for the 24 pin again, that I'm not mistaken which one is 5 VSB. So this is really weird. So if we check, I've double checked and this is 5 VSB, and we have 850 ohms, which is enough in my opinion. And we still have very high power consumption. So next thing would be to check 3 VSB, if that is getting if that is shorted, but I cannot see an obvious place where 3 VSB should be located. So what we need to do is I need to find a board view to see where 3 VSB leads, because as you saw, we have 600 milliamps of power consumption. The only power rails that are running on the main board in standby is 5 VSB, and everything that is derailed from 5 VSB, like for example 3 VSB. 5 volt dual, for example, only runs when the board is turned on. And there might be a different standby voltage as well, like the 1.05 volts for the PCH or the chipset, and that might also be shorted. But I will need a board view for that to find out where I can check those. Give me 1 second. So I've now taken off the shielding or the heatsink of the PCH, and let's check the SIO, because this could be another point of failure. Visually it looks fine, but let's see. This is its regulator, but it seems to be fine. Let's see on some of the capacitors around it if there's any short circuit, but so far it doesn't seem like that our SIO is at fault here. So all of these voltages look fine. All of these resistance values, I mean. Yeah, I think we're good on the SIO side. Okay, let's see where the PCH voltage comes from. It probably comes from 2 MOSFETs that are here. So checking these MOSFETs, checking the output of them. Let's switch on. Okay, let's go to this mode. 26, that is kinda low. 26 ohms for the chipset. For an B450, this is kinda low, which is not great. But we will continue to search, I think. If necessary, we're going to be putting 5 volts into the VSB and then checking with the thermal camera if I cannot find the short right now, just by probing around and looking at the different inductors and looking at the voltage rails to see if I can find a short somewhere. What I also would want to check is on the BIOS chips, if there's any, if I find a short on like the 3.3 or 1.8 volts, but that seems to find it's more very often it's either the 8th pin or the first pin that is 1.8 volts, but all of these look fine, so this also isn't a problem. And right now I don't really have anything more to check what would be starting in a standby. So we're probably going to go over into injecting 5 VSB into the board and see what power consumption we have and see what is getting hot. But for that we will be needing to remove this cover, because there might be components under there that are relevant for us, so we can see them also under the thermal camera, but there's almost nothing here. Okay, so I will get the setup. I will get our lab bench power supply into here, and we're going to see what gets hot. And now we have 5 volts set up on our lab bench power supply, and ground is already connected, and I will be using my tweezers now with the connected clamp to go into 5 VSB, and let's check for amperage. There you can see it flickers on once, but then all the current goes somewhere else. We have 1 amp, 1.1 amp, which is way too much for 5 VSB. So I'm gonna get my thermal camera and we're going to see who the culprit is. Okay, I got my thermal camera. Let's now see. So I cannot find anything on the front side. We have a few places that are getting a little bit warmer. Like here, we have a chip but it's only 38 degrees, and we have a few other things like down here, but they barely heat up. Like it's 35 degrees, 36, and here also 38, which is a transistor. So nothing getting hot where you would say that it is short circuit. So what we might need to do is take off the heatsink for the VRM, and we will also need to be seeing on the back side if we can see anything, because so far nothing. But there should be something getting really hot, because 1 amp on 5 VSB is like a lot. But for this I will have to get a wire attached to here. I will solder it onto the back side so I can connect the clamp to it and make it easier to inject voltage. And now we have a wire attached to the 5 VSB. So what we're going to do now, let's connect our clamps again and turn on our power supply and connect it to this wire and see if we have any difference. So we have our 1 amp of power consumption, and let's see if we can find anything getting hot on the back side. We have something here, but that is on the other side of the board. Might want to check that. This is the 5 VSB itself, where we're injecting voltage where it's getting hot. Oh, we found something. Oh yeah, look at that. 90 degrees already. Interesting. This seems to be a USB connector or something, because there's no actual component here. Is it? No, there's a component here, but it's not that. Something else there is getting hot. Okay, let's see under the microscope if we can find anything there. So something in this area was heating up really badly, but it seemed like it was the port itself and not like, for example, this component down here. Let's see. We probably have to take off the shield of the VRM and see what is under there, because there's probably some standby component that is under here somewhere that is getting hot. So let me take that off and we're going to see. And one thing I can already tell you, there's the USB-C. And this is where the problem was. So this probably means our USB-C controller is dead. That is what I would expect here. So, let's get these screws off of here. So, these always have plastic screws. These are a little bit different than most of your typical screws, because these don't have a thread, but these are self-cutting. So just know, these self-cutting screws are always for these big covers that, for example, ASUS has or Gigabyte has for the VRM cooler, and where like all of the RGB is and all of that stuff. So let's see. Oh, the cover just fell off. Okay. So very often it is that this thing has actually some circuitry in it, where there's a connector coming from a PCB going to like somewhere here, but this time there's just LEDs here that light up and shine through this. So this is even made easier for us. And let's go under the microscope into that area, and we're going to see. And this is the area I was talking of. So we have USB at the top, and we have USB-C below it. And I can already tell that there's some... Is there some decoloration? No, maybe not. So visually this all looks fine. My prime suspect would be that chip in the corner there. Because that chip is, I think, the USB-C controller. Let's get our multimeter and let's see if we can already confirm this by just seeing for resistance here. Okay, this seems to be shorted. Let's go on to here. And this seems to be fine. No. Pretty sure we found our short circuit, which is that controller. But we're going to confirm it with the thermal camera as well. So let's go on our overview again. Let's connect our probes from the 45 VSB for the power supply. Get our thermal camera ready. So thermal camera is ready. I will be holding it at the position where our controller is. And let's turn this on. Oh yeah. Oh yeah. That heats up very high. And that might also be even something else below it that is also getting warm. But it, first of all, is the controller. So, interestingly enough, another USB-C controller that is dead. We've had this before on also Aorus boards. It was X570, I think. But this will be quite challenging to remove, to be honest, because it is in such a confined space. But we will manage. Let's try to do this live together to show you a little bit of how I solder and how I go about hot air soldering. So this is the space we can work with. Let's see if my tweezers even fit into here, because I will somehow have to lift this chip out of there. And it's really not helping that these connectors here, they reflect a lot of light and my microscope can't really handle that. But that's all we have right now. So let's try. First thing I do is apply some flux. And now let's see if the tweezers will fit in here. Yeah, we should be fine. We should be able to do that. Question now is hot air. How are we going to do that? We're going to go on to 385 with 80% airflow. And let's see if I can do this. So let's hope nothing is going to melt inside these ports, because then we might have to remove them. But there's nothing really I can do about it, because the chip is here. And then another problem is I can't get the nozzle any closer to this spot, because it's just too close to connect this to too close to each other. So hopefully we will be able to remove it like that. Another thing that we could do. Oh, okay, it just moves already. Okay, never mind. It was easier than I thought. I was just suggesting maybe adding leaded solder to the mix, but that wasn't necessary. Okay, let's check for the short circuit that we had before onto these capacitors, if there's anything else still shorted here. It doesn't seem like there's still anything shorted. I cannot get a reading. So, okay, none of the parts are shorted to each other. So let's connect the 5 VSB again. to inject the voltage. And let's see if we still have the same problem, if we still have too high of power consumption, or if that was actually our problem. Let's go to on our overview again, and let's get this onto here. So the area is still quite hot, but let's now see if we turn on the power supply. We still have high power. It is, oh no, it is decent. And the area doesn't seem to heat up anymore. We have 350 milliamps, which I would say is decent for 5 VSB. And the area is not heating up anymore. It is hot because we were just soldering there, but there's nothing heating up here anymore. So I think we might be fine here right now. We're going to be connecting our 12 volts adapter to here again. Something here seems to... maybe it's just reflective. I think it's just reflecting and it's going to be cooling down. Okay. What we're going to do now is we're going to build the board up again. And we're going to see if that fixed our problem. So let's try again. This time we're going to have a look at here. And we had about 500 milliamps of power consumption before. And let's see how that changed. 200 milliamps, 170. This looks acceptable. 170 milliamps looks like a current that could be fine for 5 VSB. So let's connect a CPU into here. We're going to use the 2200G. CPU is in. We're going to use our CPU cooler. Let's see. We're going to attach our DDR tester. Let's get one stick of DDR into here. Next up, let's see for the PCI tester that I have, if I can get this into a TPM slot, but it doesn't seem like... Okay, we're not going to attach it. But what we have is we have post LEDs in the bottom right, which go from top left to the right, top right, bottom left to bottom right. So let's have a look. We also need a power button attached to here. Let's now try this. Power consumption is a little bit higher now already. Let's hit the power button. And we have nothing on the power button. Weird. So there seems to be still something wrong with our 5 VSB. But I can't tell you right now what it is, because we have no reaction on the power button. If I use a screwdriver, there's no difference. If I hit this clear CMOS, also no difference. Let's check if we have voltage on our power button even. Yeah, we don't seem to have voltage. Let's get a other ground into here. Yup. Do I have bad connection from our probes? Yes. But we have no voltage as far as it seems on our power button. Let's see, do we have voltage around our SIO? 2.5. So it still seems to be that our 5 VSB has a problem. But this might be a little bit harder to detect because there isn't much current going into there anymore. But the problem is we don't have our 3 VSB that we need on our SIO. So we will try this again. So we have 5 VSB. And let's see if still something is getting hot or not. So there's still 2 areas that are getting hot. It is this controller that we have here. There's a small one, but just 42 degrees. And we have something on this side getting a little bit hotter. But we need to flip the board for that. So let's do that. So back to the front. we have a little bit of heat up right there, but that shouldn't be anything special. So there's still definitely some heating up here, but it is very subtle. It's only 37 degrees, so there's almost nothing. But I think we will be removing that controller that we saw on the backside that was heating up a little bit, because there's nothing else that I find right now that is heating up in the slightest. And it was at the area where I would expect some problems, some damage. So we're going to check that as well. We're going to desolder it and going to see if our power consumption changes, or if it gets better or worse, or if the board now then reacts. And now the part is removed. Let's now see again if there's going to be any difference in how our board reacts to being plugged into 12 volts, having all of the voltages on here. So let's now see. Still the same power consumption basically, and still no reaction to the power button. Not nice. Not very good at all. Let's go onto the 5VSB again and see what kind of power consumption we have. If it's still a 5VSB problem, or this might be something else entirely now. Okay, so I was just double checking some stuff, and I noticed when I unplugged the 12 volts connector that this board auto starts. And I went into the 12 pin again of the CPU, and we have 1.75 ohms. This is very weird because we've checked it before and there was not a short on the 12 volts here. So, yeah, let's take out the CPU and see if this changes. And I think what we have is a short circuit from 12 volts into the phase, because that 1 ohms might be the resistance of our CPU itself. I just discovered this by accident, because what I was doing was I only had the 24 pin attached to here, and I was turning it on, and as you can see in the bottom there's an LED, and we have almost 600 milliamps of power consumption because the 12 volt isn't connected. So very interesting. Now the 12 volts all of a sudden is shorted. And let's now see. We probably have to inject voltage again, and we will have to remove these coolers in order to see what is getting hot. So I find something very interesting. I was just about to remove the cooler for the VRM controller, for the VRM heatsink. Like you can see, this is the attachment point of it. And I just found this. This is a capacitor that is ripped in half. Or like not even ripped in half, left into pieces. And the question is this shorting or not? But it doesn't seem to be shorting. Okay, no, I don't get a connection between these 2 points, but that capacitor is definitely dead. So let's quickly remove whatever is left of that. So I don't think this is our problem, because there was basically nothing left of this capacitor anyways. But just to be sure, let's check the resistance again. I don't have a CPU in here, so I will first have to get a CPU into here as well, again, to see the resistance. So let's check this again. Just look at the powers at our multimeter. if we still have the same. Yeah, we still have the 2 ohms. So I will continue with my search and will be taking off the heatsink. So let's start with visual inspection around these MOSFETs to see if we have, for example, any ball squeezage on any of these, or some insane discoloration or anything like that. This is just a thermal pad, what's left of it. But this might be an indicator that these ones got hotter than the others. So this one looks weird. Like the solder at the end of them. Oh no, okay, these all look like that. Okay, never mind. That resistor looks a little bit janky. Okay, so nothing obvious. So what we are going to do, we're going to be supplying 1 volt to the 12 volts here, and we're going to be using one end of these inductors. So let me show you that on the back side. So for this, I will be using my multimeter. So we currently have a CPU in here, and what our problem is, the 12 volts is shorted into the phase. As you can see, we have 7 ohms. So what we're going to do is we're going to be attaching 1 wire to the top here, which is the 12 volts. Pretty sure, yeah, this is the 12 volts, I think. And 1 wire to the coil. And what that means is current is going to flow from this point through that shorted MOSFET into the coil. Because what you don't want to do is want to do it on the output where the CPU is, just getting the 12 volts into the CPU, so just injecting voltage into here and into ground, because then you will be sending it through the 12 volt power connector, through the MOSFET into the CPU to ground. And we don't want that. We just want it to go through the MOSFET. So I'm going to be attaching a wire to the 12 volts here and to one side of the inductor, and then we're going to apply voltage and see what gets hot. So now we have 2 wires attached. The white one is attached to the phase, so the output inductor, and the blue one is connected to the 12 volts. And we're going to be starting with very low voltage, and we're going to see how this reacts. So on our power supply, we're going to be starting with 1 volt, but 1 volt pretty sure is not going to be enough for us to see the MOSFET heat up, because they are heat sinked very well, because they're designed to work like that. And so the black clamp goes onto the white wire, and the red one onto the blue one. And right now we have 350 milliamps. This is already an indicator that definitely a MOSFET is dead, because there shouldn't be any voltage going through, no amperage going through into our VRM area with just attaching 1 volt. And let's see now. So this is the inductor, I think, where the current is passing through. But it's weird that this inductor is getting hot, because let me double check if I went onto the inside or the outside, because I want to go into the inside. I don't want to pass the current through the inductor. Let's see that again. No, I did go onto the outside of the inductor, so weird that it is getting hot. Very weird. But let's try this again, and let's raise the voltage. If then we will be able to see. We should also be able to unplug the CPU and get the same result. So let's do this. But we're not getting the same result. How is that? Why are we not getting the same result here? Because what I expected here is that the 12 volts is shorted into the CPU power phase through a MOSFET, but only as soon as we plug in the CPU we get a problem actually. So if we increase the voltage right now, oh no, okay, there it goes. Never mind. Okay, it is still shorted. Just the voltage wasn't enough for it for some reason. Okay. As you were able to see, the amperage raised really quickly because what we do now is we apply 12 volts to the connector, or we apply voltage to the 12 volts connector where current should be anyways. So let's now increase it slightly and see when one of the MOSFETs will fail. And there we have it. There's the MOSFET that is open. At 2.7 volts we were able to find it, which is this one, that one. You cannot see that. Oh, like that you can see it. This is the one heating up, which is that one. The second one from the right on the bottom, which is open, which is closed. Like closed in a way where the circuit is closed and we have a short circuit, and open would be if there's no connection anymore. So let's turn this off and let's remove that MOSFET together and see if that will be enough to get this board back into a working condition. So let's go under the microscope. Let's see together if this has any visual indication of being damaged. But it doesn't really seem like there's any indication of this being damaged. So there's a little bit more to this than just removing the MOSFET. It could very well be that not only this MOSFET is dead, but this MOSFET is dead and the driver is dead. So we're going to start one by one by removing this one, and then we're going to see how the board reacts, and then we might need to remove this one, and we might need to remove the controller, and go from there to see if we get the board back into working condition. So let's do this again we apply Flux onto here, and this time I definitely do want to apply low-mats or leaded solder onto here, so that the melting point is going to be a lot lower, because these MOSFETs are not easy to desolder. So you want as much solder as you can onto these points. Where you also want it is this on the side right here, and you want it onto the top side here. So that every single one of these pins holds leaded solder. And let's try if we can get it onto here as well. Don't think that really helped. Well, let's just get hot air and take this thing off. So we're still at the same setting, 385 degrees with 87% airflow. Let's just blast this thing now with hot air. There we have it. It is removed. Let's now clean this up. As long as it's hot, it's mostly a lot easier to clean the area up. Let's get some IPA onto a cotton bud. So let's test the MOSFET we're going to go over here. Let's see, we have our multimeter on screen, and let's now check source and drain. Let's get it here. So it might not be this one that is open or that is dead, because we do not get a connection. So it might be the other MOSFET that is the actual bad one. But let's try the resistance check while the CPU is in there. But I would have expected now that there will be that there was a short circuit on that MOSFET, but there wasn't. So it might be a different one actually. It might be the one above it. So let's see for the resistance again. Yep, and we still have 2 ohms of resistance. So we're going to remove the upper MOSFET there as well and see if that will help the situation. So I will be also removing this upper MOSFET right here, and we're going to see if it will change now. Let's get this onto here again, and same procedure as before, applying some leaded solder to there. We have Flux on there, and yeah, we'll hot air this off then. So the next MOSFET is removed, and let's check this one with our multimeter. So source and drain, and again nothing. So the next thing might actually be the controller for this phase that is dead, or it might be the other two that get controlled by the same controller. So, but what we're going to try now, let's try again to see the resistance as soon as a CPU is plugged into here. And we still have the 2 ohms. Whew, this is difficult. This is very, very difficult. So it might be the VRM controller that is actually opening up the MOSFETs in a way that they shouldn't, and it might be the doubler that is there that is doing that thing. But what I want to do is I want to once more attach voltage to there and see how this behaves now, because we completely removed that phase, and I want to see if now just a different phase is going to be heating up, or if the phase is going to heating up that is also being powered by that controller. So we definitely have less power consumption, and let's raise it now to see when we get voltage. And now it's that MOSFET. So if this is also controlled by that controller, but I cannot imagine, there must be something else wrong here. Cannot imagine that is the same thing here. There's something else wrong here, and I'm not too sure what it is. So I've been thinking about this quite some time, because this is something I've never had before. And what I now came up with is, if we check with the multimeter, if we check from the 12 volts going into the lower parts of the phase. So we have the MOSFET, we have the incoming 12 volt side, which should be a short because this is just 12 volts to 12 volts, and then the output side in between the high and low side MOSFET, there is almost zero as well, or basically zero, and that really shouldn't be. So there is a high side MOSFET, I think it's a high side MOSFET, that goes from 12 volts to the 1 volt, that is shorted and leads to this down here, if I'm not mistaken, if I got my thought process here right. And what I did now is we have 1 volt at our power supply. We have the 1 volt attached to the 12 volts right there. And what we're going to do now, what I want to show you, is taking the ground clip, attaching it to this tweezers right here. And now have a look. I cannot hold this for long because the power consumption is going to be 10 amps. As you can see, it's 10 amps. It's getting really hot, really quick. And what is heating up is that MOSFET right there. This high side MOSFET seems to be leading the voltage into here. And this is what I would expect from a shorted MOSFET, where there's instantly really, really high power consumption because it's just open. And yeah, I think that might be actually our culprit. And I will be removing this, and hopefully when we have removed this, we will see that it was shorted. And yeah, let's continue as soon as I have unsoldered this MOSFET right here. It is shorted. Finally, we have found the culprit. This has fooled me. So what has happened there was, why did I think the other two were shorted? So what had happened is the 1 volt got into the 12 volts and was led straight into the middle here. And it happened that this MOSFET showed that it was open. It happened that this one was the first one to lead the voltage or the current into the socket, or like to the ground clamp. I'm not too sure what determines which one opens up first or which one is active, because the gates should be low because there's nothing else attached to it. But you were able to see that this one was leading the current, this MOSFET right here. But we were able to determine by checking its source to drain that it is actually not open, that both of these were working fine, but actually it was this one that was shorted. So let's now check from the 12 pin again. Let's insert a CPU into here and now check the 12 pin connector. And as you can see, we have kilo ohms and rising, with a CPU installed in here. Oh, this is great to see. Okay, this took quite some time. Let's now attach this to a power supply again and see if we can finally get a boot out of this. I'm not too sure how this board is going to react to so much of the phases being desoldered. Like, there's one phase completely desoldered and another one is missing one MOSFET. So let's just try it out and see if this board will react to it. So now let's look at our passive power consumption. And we have 1.3 amps. This is auto starting, which is interesting. And we seem to not be able to turn this off. But this goes a lot further now. So we have a CPU LED still, but the board now goes into startup. So that means our passive voltages all start up, which is what we wanted to see. But there's still some problem here, where either it is because of the missing phases, what I would expect, or some of the VRM gets very hot. I just feel that. Yeah, I think it's because of missing phases that we have. This doesn't start up. Let's try a different CPU in here and see if that changes. But I think it's just because of the the missing phases. So this again auto starts, still stuck on a CPU LED though, and some of the phases get really hot. So I will have to source. I will have to resolder these two because these two were fine. So get these two MOSFETs into here and find a replacement for this one, and then we can check again if our board turns on or not. So the two MOSFETs are now back in place. They're not looking the greatest, but they're there. And if we now go onto our onto resistance mode, we now check. We go to the 12 volts and see for the phase. We have OL, and if we now again, let's take a CPU. Let's put it into here. Now with the CPU installed, the 12 volts connector still has OL. So let's go into a higher ohms range. And we still get open line. So we have no short circuit anymore on a 12 volts. And we have this phase installed that I will clean up a little bit around that phase. It might be that we do need the one MOSFET that was shorted also replaced in order for this board to turn on. But we're going to be trying it without that one phase, and we will see if the board will be okay with that or not. So we have 1.2 amps of power consumption, a little bit less than we had before, but we're still stuck on a CPU LED. And still some of these phases get hot. So I would be expecting that we still need that one MOSFET that is missing there. And I will now go to one of my donor boards and see if I can find the MOSFET that I will need. So as luck would have it, I actually have new ones of these. So I did have replaced these before and had bought some. So I can even solder in a new one onto here, and let's see if that will fix our problem. And now yet again our board is built back up. Now with every phase installed, but there's still some possibilities, like there still could be the PWM controller or the controller for the gate driver of that those MOSFET could be blown. There could still be our VRM controller that could be that. And then there's also the knocked off capacitor that we saw at the back that has to do something with it. And if there's one knocked off component, there might be other ones as well. So there's still a lot of possibilities for this to not work. But let's now see for the passive power consumption. Or like it auto starts, so let's see for that. We have 1 amp. And we have no movement at all of this board, sadly. The phases though don't seem to get as hot as they did before. It's weird that our power consumption went down. But I just cannot get this board to not auto start up. It just always is on already. But we still have nothing. Still stuck on a CPU LED. Cannot get it to turn off or on. Stuck in that loop. Even if I hit reset, it does the same thing. Or if I want to clear this CMOS, it does the same thing. It's still stuck here. Okay, let's now, I will go into the board view and see what that capacitor was responsible for. So I've now replaced this capacitor. This, as far as I have seen, was a 220 nanofarad capacitor. So let's now turn this over and try again. So let's see. Let's turn this on. And the power consumption yet again is a different one with 1.2 amps. But we still have no movement at all. Nothing happening. Still auto starting. Don't know why. Power consumption seems very static and not reacting to the power button at all. Nothing happening. Nothing happening when we hit reset as well. And nothing happening when we try to clear CMOS. So this is stuck still. So there's multiple possibilities. First one that I would think is that there might be still some knocked off components somewhere, or some damaged ones. There might be a problem with the BIOS for not recognizing the CPU, but there's still so many different things that could be wrong with this. So because the video is already really long, I will be only getting you back as soon as I've found something or got any further with this board. So while doing visual inspection, I found this diode that looks awful. This has about 160 ohms of resistance to it, which I wouldn't instantly say that this is a problem, but by the way that it's looking, this can't be right. Like, this thing looks like it heated up a lot. So I will be removing it, and we will see if that will have any difference for us. And as you can see, this diode just fell apart on its own. Like, this thing was dead. But sadly, still no change. Still stuck on a CPU LED with the same power consumption. So I've spent quite some more time on this mainboard, and I did attempt to flash the BIOS, but that didn't make any difference. And I also swapped the BIOS chips around, swapped the backup BIOS onto the main one, and that didn't make a difference as well. But one thing that did make a difference is I took out the CMOS battery, and now the board isn't auto starting anymore. So if we turn the power on, as you can see, the board doesn't auto start anymore. So there isn't the LED on for CPU, and we still have the normal power consumption. But now what I've noticed with my PCIe tester, as soon as you try to turn on the board, it goes to its power consumption that we had before, stuck on CPU LED. But if you can see this, the red LED is on, which means PCIe reset is stuck on this board. So there has to be something with the Super I/O that keeps this board in reset state. And I think it will be something around this ITE controller that Gigabyte uses. But we're running out of time. We had quite some good fixes already, like we had the shorted controller for the USB-C, we had the shorted MOSFET that was quite hard to find, we had the broken off capacitor on the back, and we got really unlucky that this board is still not working, because most of the time you have a single fault on a board and not have multiple like we have here. Like, having multiple different things that are unrelated shorted is just so unlikely on a mainboard. Like, I really can't tell you how this board is still not working. But because the video is already very long and we have a second board to fix, and I don't have the fix for this one yet, we will be splitting it up into two parts. I have some good footage already and something I could teach you with these fixes, and hopefully we can go all the way in the second part and maybe even fix the other one as well. So thank you very much for watching. Thank you for being here. Like and subscribe to the video to keep up so you won't miss part 2. This was Motherboard Medic. Thank you very much and goodbye.